Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. With this video, we're moving on to the next chapter. We're starting to talk about multithreading. Multithreading is a concept that has really taken on a significant increase in importance in the last, since 2005. So at the time I'm recording this, in the last 7 years. And the reason for that is because of a change in hardware. So we're going to write some simple code. We're going to start talking about multithreading from the standpoint of basic Java libraries, but we should talk about a few things dealing with multithreading. So first off, we'll go ahead, we'll create a little object here that has a main inside of it. And there are two terms that are significant here. There's concurrent programming, and there's parallelism, or concurrency and parallelism. So when Java was created, now Java was actually in many ways way ahead of its time, because the creators of Java put in a java.lang.thread class. And because Java Lang is imported by default, you can just call it thread. And we'll start off just using thread. And thread gives you concurrency. And so when a program is executing, so for example, let's take our client main here, and let's just go to the, so let's see, somewhere, somewhere like in here. Okay, when execution hits here, it will do this line, followed by this line, followed by this line, followed by that, followed by that. And this is doing sequential execution. Now, every so often you get to a function call or a method invocation, and then it jumps someplace else. So for example, this jumps into the server main, and then it starts running over in here, and it does this and this and this and this. Okay, so it can jump around, but I can point to one line and I can say that's what's executing right now. Yeah, well, that is basically a single thread of execution. And in a concurrent program, you have multiple threads. It would be like me having multiple mouse pointers, and I can point to one line that's executing in one thread, and I can point to another line that's executing in another thread. That's what concurrency does. Now, by default, concurrency does not have to mean that they are happening at exactly the same time. If your computer only had the ability to execute one thing at a time, concurrency would mean that it was alternating back and forth very quickly between two things and doing it in a way that the programmer didn't have like exact control over. And prior to 2005, unless you owned a big expensive computer, this was what you got, because you had a computer that had a single processor with a single core, and it was able to do one thing at a time. And starting around 2005, the chip makers, Intel, AMD, IBM, Sun, and others, took a change in their approach. And the reason for this basically was because the laws of physics said you're not going to make your chips run at higher clock speeds. And there's a nice figure in the book that demonstrates this. And so Moore's law continued, and they continued getting more and more transistors, but they weren't able to go to higher and higher clock speeds. So instead what they did was they changed the way they were building their chips so that their chips all of a sudden had multiple cores on them. So if you have twice as many transistors, what you do is instead of like putting in extra cache or extra control logic or anything like that, you just take and make a copy of what you had before, and then each one can be running a part of the program at a time. And when you have concurrency on a machine that can do multiple things at once, then you get parallelism. And so starting in 2005, basically almost all the new chips that were coming out, especially for computers, for larger computers, had multiple cores, and all of a sudden parallelism really mattered. Prior to that, it didn't matter to the consumer. But starting in 2005, all of a sudden lots of stuff started being parallel. And at the time I'm recording this in 2012, your cell phones are multi-core. It's hard now to buy a processor that isn't multi-core. And what that means is that if you really want to utilize the hardware, you have to multi-thread. So for example, if I'm running on a machine that will handle 8 threads, if I write, most of the programs we've written so far only use 1 thread. And that means that you're only going to use 1/8 of the power of your computer. And that's, that's underutilization. So we need to have a way that we can take advantage of multiple threads so that we can make our programs run faster and utilize the new hardware that's out there. So we're going to start by looking at just how we can do this using in some ways, the old school Java libraries. Like I said, Java was really ahead of its time in the sense that it gave you the abilities to create and use threads. And so we can make a thread by saying new thread. And then to make it so that it runs something that we want to have it run, I'm going to pass in a new runnable object. And if I save this, I should get an error here. And it says, well, you can't make a runnable because runnable has to have a run. And so we can put a run method in there. And what this says is that we're making a new thread of control that when it starts, and right now I haven't started it, when it starts, it is going to execute the run method of this runnable object. Okay, so what do I want this to do? Well, I think what I'd like to do for a simple example, and just to show that it is a separate thread of control, is I'm actually going to write a little for loop. I in 1 to, how about I go to 15, okay? And inside of here I'm going to print line the I, and then I'm going to tell this thread to pause for a little bit. Okay. So there's this command in thread with an R called sleep, which tells the thread to stop executing for a while. And how long, you have a call that takes 1 argument, and that 1 argument is measured in milliseconds. So 1,000 of these would be 1 second. I gave it 200, so this is going to pause for 1/5 of a second. It's going to print 1, and then it's going to pause for 1/5 of a second, and then it's going to print 2, and it's going to pause for another 1/5 of a second. And to make this actually happen, I need to call start. And so if I do that, I can run this program, and you can see what we get down here. It prints up to 15, and it did it slowly compared to what it would have done if I didn't have those sleeps. But that doesn't show you that this was actually running in a separate thread. To do that, I'm going to do something else in the main thread. Okay, so I'm creating 1 thread here, and then I want to have, but our main continues going. So calling start, instead of this happens off to the side, and then this continues to go on. And so what I'm going to do is I'm actually going to make another loop that runs through characters. Okay? And so I'll print line my character. Oops. And I'm choosing characters here. I did numbers here and characters here. That way it's very easy to distinguish what thread is printing what. And I'll sleep for 100 milliseconds on this. And now if I run this program, you can see what happens. You know what to scroll. There we go. It prints out A, followed by 1, followed by B, followed by 2, C, D, 3, E, F, 4, G, H, 5, I, J, 6, K, L, etc. And down in here it's kind of hitting this nice trend because one was pausing for 100 milliseconds, the other was pausing for 200 milliseconds, where it prints out 2 letters per number. You'll notice that some odd things happened up in here where it wasn't quite on that nice pattern where it did letter, number, letter, and then from that point on it's number, letter, letter, number, letter, letter, number, letter, letter. One of the things about threads is that you really don't have control over when one thread is going to be executing relative to another unless you use additional features. And so a lot of this chapter is going to be talking about how we can get threads to work together. For this example though, I just wanted to show you something basic where I have 2 threads and they're not working together. Just to show you that basically this is happening at the same time that this is happening. And we could add more threads in here, and they would all be happening at the same time. And so we need to, in this chapter, we're going to talk about how we can do this with the basic Java model, how we can do it with Java's advanced libraries, and how we can do this with Scala-based libraries. And plus what the pitfalls are and how we avoid them. So that's it for this video, and we'll come back and continue talking about multi-threading next time.